Okay, thank you everybody for having me here. Thank you Attila for the kind invitation. I'm Luca Sandrini. I'm from QSMS at BME. I'm working on topics related to I/O, theoretical I/O, in particular on innovation and incentive to invest in innovation, in particular like analysis on how to evaluate the value of the patent in terms of licensing revenues. The paper I'm going to present today is about this. It's part of my healthcare project, and it's about the incentive of an innovator to sell an innovation in license with per unit royalty. And in particular, I'm going to focus on the incentive on how many firms to supply, and eventually, if not all, which one to supply strategically. The literature on the topic is quite rich and quite well developed. We date back to the 80s with the seminal contribution by Katzen-Shapiro and Kamin and Tauman, and has developed since then following the kind of a similar focus over the years. And the focus is what is the best selling mechanism that an innovator can enforce in order to maximize the revenue from licensing and thus maximize the value of a patent in itself. During all this year and during the existence of the scholarship, one common assumption has been made, which is in order to evaluate this value of the patent and the best strategy of the innovator, we want to reduce any other confounding effect, and we're going to focus on the incentive of an innovator, which is either outside the market or inside the market, but is competing or serving firms that are producing the same good or horizontally differentiated, but with the same technology. The assumption of heterogeneity might actually emerge in the context of horizontally differentiated products, but as we come to analyzing licensing of a process innovation, firms are usually taken as homogeneous in that belief. What does it mean? It means that they all produce the same technology, the same product at the same cost. And the analysis is what the innovator should do in order to sell the innovation, so to maximize licensing revenues. And then, of course, might imply that different selling mechanism implies a different market coverage of the innovation. Usually, with royalty licensing, the common result is that the innovator should sell the innovation to all the firms in order to maximize royalty collection, because this is a selling mechanism leveraged on quantity, whereas other selling mechanisms, such as upfront fees or auction, also might actually create asymmetry in the market that the innovator want to exploit, so that you might want to serve only a part of the market, so some firms, and leaving the other one with the obsolete technology, competing with an inefficient technology. There are exceptions, of course. The main one is the paper by Crane, which is the one closest to this analysis. But the paper by Crane is not actually on innovation, it's more on a technology transfer. So it considers a firm which is competing in the market, who does not produce an innovation, but sells its own technology to other firms. And the firms itself may or may not be the technological leader in the market. So it's not technically falling into the umbrella of innovation, but yeah, it's the one closest to my analysis. Now, this analysis will depart from the assumption of homogeneity in the technology domain, and will assume firms are different in their cost of production. And of course, because of this, it also implies that the cost reducing effect of a technology, of the same technology, will affect the firms differently. That, of course, reintroduce some asymmetry that the innovator may or may not expect. And the main contribution of this paper is to uncover a tension that was just sleeping in the literature developed since here, which is the one between what I call price effect and market share effect. The price effect means that because of the differences in technology, in the technology domains of the candidate licenses, the innovator may actually exploit difference in willingness to pay, and so can actually have a more richer price strategy. And the market share effects imply the fact that when you're serving firms that are different and that covers different share of the market, you might want to decide which one is the best one in order to allow the innovation to have the broader market penetration and thus collect more royalties into them. There is a large consensus, which is quite adamant in that respect, that with pure royalty licensing, per unit royalty licensing, the result is that there's full diffusion of innovation. Pure diffusion in innovation means that all the firms buy the technology at the same price, and the market becomes a more efficient oligopoly, but without exit. This was true in the seminal paper by Tauman and by Kamin and Tauman in '86, and it's true also, let's say, in a more recent paper by Sen and Tauman, which basically confirmed the results that they found previously 40 years ago. Now, this is indeed where I'm going to contribute more, or where I hope to contribute more. There are very few exceptions to these results, to these full adoption results. One is the paper by Lapan and Muschini that exploits a setting with a complex production function of the firm. So if there are multiple input of production and the innovation affects the efficiency and the price of one input, that all in turn change the demand of all the inputs, which affect the prices of the inputs in turn. And some firms may actually prefer to go on with the obsolete technology because it's actually cheap. The other one is by myself, which says that when innovation is sufficiently large, the innovator has a counterintuitive strategy, which is to offer a discount to a restricted number of firms in order to allow them to expand their output, kick out of the market the inefficient firms, and let's say create a more efficient, although more concentrated oligopoly. This creates a market expansion that may offset the discount in price that the innovator is actually proposing. This paper instead will remove the assumption of homogeneous firms, and I will try to convince you that the show effect, which is simply sleeping under the assumption of homogeneous technology, can actually lead to partial adoption of technology and alter the optimal choice of the patent holder with respect to which firms should I serve. So if not all, so which firm should I serve? Just to give you a little bit of possible application of this analysis in real world terms, there are three examples that I want to present to you. One is basically those vertical industries where the performance of the input limits the performance of the final product. That might be in semiconductor industry, chip architecture. So basically, depending on the chip architecture, the producer of digital or of technological products have some limitation and standardization in the performance that they can produce. But more close to what I'm actually, let's say, more relevant are the one that the examples that goes in the direction of standardization of the process of the final good. One may be all those technology that are, let's say, aimed to maximize efficiency of labor in a given environment. But the most interesting one is actually services in digital market. And I bring the example of fulfillment by Amazon, because it's exactly mapping almost in one-to-one the analysis that I'm going to propose. The fulfillment by Amazon, I presume you are all aware about it, but I'm not going to explain in any case. It's a service that Amazon Marketplace provides to all the sellers that are on the marketplace of Amazon. Assume I'm an Italian, so let's ride on a cliche. I'm very fond of coffee, and I want to buy a mocha, a coffee machine. I write Mocha on Amazon, and what happens is that I will see a list of products, the same product actually. So it's a kind of a Kurno market. So one Mocha and different sellers. Those sellers are different, so they will face different costs in many aspects. One of these costs is the delivery and the shipment and the final handling of the product. Then, so they have to pay usually the courier and the packages and otherwise, they can subscribe to fulfillment by Amazon, and basically Amazon will take care of all this part of the selling. So it's basically outsourcing the final step of the selling to Amazon, which is far way more efficient than each of the competitor of the seller, and which apply a fee which is per unit and depends on the size of the good. So within the same market category, there's no price discrimination. Price discrimination is regarding the size and the weight of the product. So if we focus our attention on a single market for a single product, there's no price discrimination, and there are sellers, some sellers that that subscribe this service and pay some per unit fee, and others don't. And that is exactly the environment that I want to propose in my model.
Who is innovating here?
In this case, Amazon is introducing a service that makes the process cheaper.
Yeah, may I ask a similar question?
There's a question from the audience.
Sure, but the volume is very low.
Yes. Can you write it down, Attila? Yeah. Okay. Let's try again, please.
So I'm somewhat,
Sorry.
okay, probably it's better if I try to write it down. Or is there an echo now? So I'm confused because in this case, it is not a process innovation introduced by a company,
Okay.
but it is a service offered by Amazon. So it doesn't seem like a company is buying a process developed by an inventor and sold to several companies. And for the semiconductors, the chip architecture is not a process innovation either. It's a product innovation.
Well, it's a product innovation in the eyes of the innovator. It's a process innovation in the eyes of the manufacturers. They are using that in order to produce another good, and that actually improve the efficiency of the process itself. I'm mostly focusing on the Amazon example. Maybe with the architecture is a little bit of a stretch as an example, but in this case is a digital product, a service that Amazon supply, but which affects the process of the selling, which is part of the usual, production consumption relationship between consumer and firm. Usually you say, well, there's an output that is sold. Well, the producing of this output also contains the cost of delivering, and so to some extent, yes, it's not a linear cost reducing effect in the meaning of I'm not adopting a new input that allow me to save on some energy or some other aspects of the production process. I'm outsourcing my service to someone else, but that is of course has an impact on my process, and this impact affects my cost, my linear cost at the end of the day. And because those are linear and basically marginal, so it's for any unit I ship, I have to pay something. That is actually as a cost reducing technology.
Apparently, we are using absolutely different terms, because in the innovation literature, process innovation doesn't mean buying an input. Process innovation means changing your process, either as the way you produce your goods or you sell your services. So it's not about input, it's about processes on the one hand. On the other hand, in this case, as I already said, it is not an innovation bought, it's not an innovation process bought by a company and introduced in its own processes. It is simply a service.
Okay, I see what you mean. I think it's a fair point. Nevertheless, the result is an improvement in the efficiency of the manufacturers, who reduces their cost. And from a, let's say, at least from a modelistic perspective, that is as we are talking about adopting something that change your cost structure and it reduces that. So just to give you an example, sorry, citing the previous literature, basically what we have is just a cost reduction by epsilon. That means your marginal costs are actually now, after the adoption of these things, which might be or may not be a new product or a change of the organization of your production process, the result is a reduction in the cost function. And at least in the literature, the definition of process innovation is something that reduces cost. A product innovation is something that opens new market or improve your product quality. I agree there might be some confusion in the definition. Sorry for that. I should have explained probably earlier in the talk. Thank you for pointing it out. But that is what I mean for process innovation. So something that is both or developed by a company that ultimately reduce the cost of producing a good. Okay, thank you very much. Okay, so without further ado, I will go to the general framework of the model. I'm going to offer a general analysis focusing on two cases. So the innovator might sell the licensing either exclusively, so there's some by assumption some exclusivity in the contracts, and only one of the manufacturer receive the new technology, and then I relax this assumption and allow all the firms potentially to buy the technology. And then I will give you a more particular example, making some assumption on the linear demand, on the demand, and spoiled it's linear, and see how the analysis goes. So for the general framework, what I need is a continuous mass of firms, continuous mass of technology that goes from a lower bound to an upper bound. The C indicates the cost, the marginal cost of production of the firms. So technically speaking, C lower bound is the most efficient technology, and C upper bound is the least efficient technology. Assume that each technology which are uniformly distributed between this interval, is allocated to one and only one firm. So we can rank firms in terms of technology. All the firms produce positive quantities. So of course, we don't have problems of negativity in the function. And I assume that the production of a firm, it depends on its own cost. So how much I am efficient. So and on the other one, and this is as to say that the production level depends on the rank. So if my ranking is higher in this domain, I produce more, and therefore my market share is actually large. That is as to say more efficient firms produce more in terms of quantity, because their cost is low.
So is there any capacity constraint, or why there is
no? I'm not assuming any capacity constraint.
So the amount firm should be the winner. Not
necessarily.
Why?
Because we are competing in quantity, so not in prices.
But if I'm able to produce in infinite quantity.
Fair point. Fair point is an assumption, but yeah, fair point. Yeah. If they were able to compete in prices, then you have only one price, and so probably this is implicitly assuming there's a capacity constraint. Yeah, yeah. Thank you. That's fair point. But yeah. So for now, we are considering quantity competition, and And okay, and what I'm assuming is that there is an innovator who has a technology, who has something that allows firms to produce at a lower cost. This technology is actually better than the best available in the market, so that any firms has a strictly positive willingness to pay for this technology. And I assume the licensing scheme is a per unit royalty. So technology is a common good, so everyone knows which technology the other firms have. But I assume there is no room for price discrimination. So the innovator cannot sell at different prices the same technology to different. Well, if some firms adopt the new technology, it means that the new cost function looks something similar to this, which is the new cost of production plus the royalty that he has to pay in order to use this technology. And that's assumed to be per unit, so enters in the marginal cost of production. Of course, the implicit participation constraint of the firms is that this cost should not exceed what they were using, what they were paying before. Otherwise, that represents technically a decrease in efficiency. So it's not, they are going to refuse anything, any price that exceeds CI, the difference between the old technology and the new technology. The old cost and the new cost. All firms produce, of course, a different cost, and that means that everyone has a different willingness to pay. And in particular, the least efficient technology have a larger willingness to pay because the new technology allows them to produce to a cost which is far below their original cost, and therefore they are willing to pay something a little bit more in order to use it. But giving the technology to inefficient firms means that the number of royalty collectors are going to be reduced by the fact that you are serving someone who is covering a smaller share of the market. And I'll be more clear at the end of this slide with an example. The opposite happens with most efficient firm, which has the lowest willingness to pay because its own technology is already quite efficient. And so the willingness to pay to a marginal improvement is not as high as the willingness to pay to a massive improvement. But the market penetration of the innovation by licensing the most efficient firm would be large. That's why, just consider an example. There's two firms, I and J. I is more efficient than J. Now, if the innovator license firm I is going to produce something that is this, so the new cost and the royalty, and competing with this firm here. If I serve J, this is going to be the cost of J, which is the same. But now the competitor is going to be more efficient than it would be if I license the other one. So this market share is strictly larger than this, which is a consequence of this assumption here. And it's basically what you found in standard good no competition models. Yes.
Sorry, I missed something, but why doesn't the C star have an I index? So how do I think of this?
It has it. It's I and J. But here I'm assuming, let's assume that this is the same for everyone. So even if those two firms are going to pay the same, so even if their own cost is actually going to be the same ex post, then because they are competing with firms that are different, that have different technologies, this is enough to assume that this is going to be larger than this. If I introduce the fact that this is I and this is J, this is going to be lower than this, and this is even more pronounced. So even assuming that this is zero, so they don't pay for it, this is enough for saying the market share of the efficient firms is going to be larger exposed than the eventual market share of the less efficient firm, just because the competitor is different and you're competing with a less or relatively more efficient competitor.
So
So in your world, there is no possibility for leapfrogging.
For leapfrogging, technically, yes. Yes, there is.
So
In this-
more backward firm can jump ahead.
Technically, yes. Technically, yes. It's not optimal, but yes, technically it's possible. It's not optimal because I will show you a little bit later more in detail, but one of the strategic choice of the innovator has two strategic choice. One is this R, so the level of royalty, and the other one is I. So which firm I should serve or start to serve. Now, if I serving more firm, I is going to be one of the basically the least efficient firms in the group. But yeah, I will be more clear later on. Then standard maximization says that this optimal price here should be larger than the participation constraint. So this is going to be skewed to the participation constraint. And that, of course, offset the possibility of leapfrogging because it's the innovator that doesn't want to leapfrog. But assume that I'm serving more than one firm and I'm setting so that this guy is going to be indifferent from the old and new technology. All the other one are going to, improve their technology up to this. So we don't have technically leapfrogging, but we are catching up. I'm going to show you that this that I briefly described. Oh, sorry.
Will you make a functional form assumption about the firm level demand function?
I will later on, is the spoiler before I will provide you an example with a standard Cournot. Now is the first with a linear Cournot function. I guess that I have some properties that the function firm has to satisfy, and that is that it should be, of course, behave in price, and it should be sufficiently elastic, so it cannot be completely reached. Otherwise, there's no variation in the market share that the firms are exploiting. But yeah, I will show you an example with a linear demand function later on. Okay, so this is again repetitive movement is again the trade-off I'm willing to exploit. And the first example that I give you, the first scenario that I will present is the case where there is an exclusive agreement. So this is a simplified version, and the innovator can choose any firm, but just one firm. And I'm going to relax it in a couple of slides. So if this is the case, the royalty rate should be something that depends on CI because it's subject to a participation constraint. And indeed, the optimal royalty rate is above the participation constraint, so it's going to be exactly the participation constraint. And it's positively depending on the participation constraint. So the less strict is the participation constraint, the higher can be the royalty rate. Potentially, if the participation constraint exceeds the optimal price, that would be the monopoly price.
Sorry, the innovator and the patent holder are the same person?
Are the same, yeah. Here in this case, I'm focusing on the patent holder because the innovation stage has been is neglected in this work. The innovation is there. So if we look at the FOC, we have clearly two components. One is the variation in the price of the technology, so what I call the price effect. So how much if I change, because technology are ranked by because firms are ranked by technology, the problem is to find the optimal I, but it's the same as to find the optimal CI because every firm is allocated to one technology. So that's simplified maximization.
The question is which firm is the innovator choosing?
Yes, exactly. And this component here is the price effect, basically how the royalty rate change if I move upwards in the ranking, so towards the least efficient firm. And this is the market share effect. So how the quantity, and because of the quantity, the number of royalty that I will collect change as I move again, upward in the range, so towards the least efficient, so downward. So with this in mind, this is the lemma that I can derive, is, well, define this component here, which is the minimum royalty rate that the patent holder can set in order, sorry, the maximum royalty rate that the patent holder can set in order to sell the innovation to the most efficient. So C lower bar is the most efficient firm. So, and this is the price that the most efficient firms is willing to pay, and define it as an epsilon. Whereas the quantity of the least efficient firms is going to be defined by epsilon. So if epsilon goes to 0, so if the new technology is not very, it's not very cost saving, so let's say it's not that good with respect to the best one available on the market, it means that the price effect is strong. What does it mean? It means that if I choose the most efficient firm, so if I choose in order to maximize market share, then I'm going to lose a lot in terms of price because my price is going to converge to 0. So any gains in terms of how many royalty I can connect is offset by the fact that the price is going to decrease by a lot. So what I want to do is I want to exploit the asymmetry in the market, and I want to serve some firm which has a larger willingness to pay, proposing a different royalty rate that is only only that firm is going to accept, and then selling, maybe collecting less royalty, but to a significantly larger price. Vice versa, if eta is going to 0, it means that the market share of the least efficient firms is negligible. Meaning that, of course, if I can maximize the price by setting the largest possible price, and that will nudge the least efficient firms into buying the technology. But the number of royalty that I will collect in the end is going to be negligible and is going to offset any gain in terms of price. So in a situation in which these two are going toward to 0, we have a bell-shaped function, and the innovator wants to choose one firm in between. So this is true with exclusive licensing. I'm going to show you non-exclusive licensing. Non-exclusive licensing just relaxes the assumption that only one firm can accept the new technology. And by the assumption of the model, that means that if I set a price that is compatible with the participation constraint of firm I, it means that all firms less efficient than I are going to accept that price, because by definition, their willingness to pay is larger than I. So that means that the choice is not to select which firm to adopt technology, but until which firm you want the market to be called. And in this case, we have catching up indeed, because define C bar minus CI as the number of firms. Now you can basically define that as the number of firms with a cost that is larger than CI. Then, of course, the production function, the quantity that each of these firms is going to produce is going to be standardized. They're going to pay the same new cost times the same technology, because I cannot price discriminate. So the price is the one that makes I indifferent from accepting and non accepting. The other ones are all willing to accept the new technology. One may wonder, well, is it possible that there's kind of an unraveling situation where one is indifferent between accepting and non-accepting, but it does know that if all the other firms accept, that means that the cost function of all the other firms are going to improve. That means that the market is going to be less unbalanced, and their position is going to be actually worse enough, because now, before I was a rather efficient firms competing with many inefficient companies. Now I am one of the many efficient companies. So my market share is going to be a little bit reduced by that. So one possibility is that there is an unraveling situation when the indifferent firms decide not to accept, but that is actually not dominant, because all the other firms are willing to accept, and given that all the other firms are willing to accept any moment, that is the adoption is guaranteed. Well, with this in mind, we can repropose the same problem of the patent holder that has to maximize revenues with the same participation constraint. If I want to serve until firm I must be at most indifferent between buying and not buying. The fork is actually a little bit more, there are more components, it's actually richer. Now we have the same price effect, which is the variation in price given by moving upward in the ordering of the technology. And now instead we have an effect that is mostly depending on the variation of the number of firms that I'm willing to serve in equilibrium. So now if I choose firm I, it means that all the firms less efficient than I are going to adopt the innovation. So if I choose an upper I, it means that I also reducing the number of firms that are going to adopt the innovation, and this is something that makes the market share effect quite large. Well, even in this case, so there is a tension, and even in this case, if we follow from lemma 1, we have the same situation. And to prove that, we need to make some restriction on the demand function. The first and very simplest way of doing is a oligopoly Cournot model with linear demand function, which I'll present you here. So, is there any questions since here before the application? Okay. So, that's a standard Cournot oligopoly model which satisfy the condition in the general framework. So we have a linear demand which is depends on the total output. The total output depends on the production of all the company. There is a ranking of technology that imply a ranking of the output, and the production level of each firm depend on each own cost. So the larger my cost, the lower my output, and on the total cost, on the cost of all the other firms. So the larger the total cost of all the other firms, the larger is going to be my output, because I'm more efficient, I'm relatively more efficient. So there's an innovator who has better technology. Yeah.
So I'm not a purist, but I do not think this model, if your marginal cost is constant, then buy only the most efficient firm survives and compete out everybody else.
Okay, that's, I think it's related to the question before. Here I'm assuming a Cournot competition model, which of course now that I'm forced to think about the things, it has to implicitly assume that firms are constrained in the output that they can produce. So
if they are constrained, then and that's the real question. If they are constrained, then by their market share or their quantity changes once their cost.
Well, that is actually simpler. Then you can relate CI to the capacity constraint. So your cost implies that you are actually bigger, and therefore you might be able to have a larger production fund, a larger share of the market. So you have firms that are subsequently smaller as you go up to in the technology ordering, because you have economics of scale, for instance. So a larger firm is able to produce.
I'm not sure whether it's tractable or not, but for me it would be much more convincing to have a model where goods are differentiated and imperfect substitutes, like in a Stiglitz model. I do not know whether it's solvable or not.
I think it's easily extendable. It's easily extendable, actually.
And it would help a lot because it would pinpoint the size of the firm. Okay. And cheaper firms would be like.
Okay, that's actually a good question. A good suggestion. And what I'm doing, I'm actually following the literature, so it's not really a matter of me simplifying the things a lot, but I see your point. I think it's actually fair. So yeah, thank you. I will move in that direction. So basically, having something that makes the products actually different, so that the effect of the production on the total output is not the same for all firms, basically. Okay, thank you. Well, with this in mind, what I can do, I can replicate the model that I have presented above. So at least, let's say, at least it's a mapping of the model of the general framework, which gives us some ugly formulation for the revenue of the consumers and a proposition that says that whenever this condition is satisfied, so whenever my willingness to pay for the new technology relative to the willingness to pay to any other firms exceed the share of the market, the inverse of the share of the relative share of the market, which is my share of the market and the share of the market of my rivals, then whenever this condition is satisfied, the patent holder will choose I. So for any K, whenever this condition is satisfied, I is exactly the firm that the patent holder want to start serving, and all the other firms that are less efficient following that. Which can be, I give you just a numerical simulation just to spare you calculation. In this example is a model that is set in order to fix the market share effect and changing only the price effect. So on the vertical line, you have the cost of the actual level of the efficient technology from not very efficient to very efficient. We have 10 firms with costs that are ordered from 1.1 to 2 by a 0.1 increase. So 1.1, 1.2, 1.3, and so on. And you have, the 10 firms here. So the numbers are the profits of the patent holder if I choose to serve I as the first firm in the market. So meaning that if I serve I equal to 5, it means that 5, 6, 7, 8, 9, 10 will buy the technology, and this revenue here reflects this scheme. And as you can see, if we move down on the vertical line, we are saying that the epsilon in my lemma is actually increasing. So it's becoming different from 0. Why? Because now the minimum price that you can set in order to attract the most efficient firms is already quite large. So the firms can actually focus on maximizing the number of royalty collection, because the price is already reasonable and I don't have to exploit too much the asymmetry in the market. Whereas if I got closer to 1 and 1.1 eventually, it means that epsilon is converging into 0. And that means that I want to set a price which is larger than the one that I would set to firm I, and eventually I will start serving from firm 5. And as you can see, there's a clearly, what do you call it, north-south-west diagonal going on, which reflects the fact that the larger the larger epsilon, the stronger the price, the weaker the price effect, and therefore we have the tension that I described in the lemma. The same result, I don't have it in the slide, but the same exercise can be done by setting C star and altering A. That would mean setting the price effect and moving the market share effect, and we can have the same result. Now, this is basically the main result in terms of the analysis and in terms of the incentives of the patent holder. And the analysis says that, well, technically the adoption of the technology by all the firms in the market is driven by the assumption that all the firms in the market are equal. And if that assumption is not really satisfied, then indeed, the patent holder can exploit the asymmetry in the market and can have a price strategy even in the case of a royalty licensing case, and that gives him a richer set of strategies to implement and actually a more interesting problem to solve. So how this affects the welfare? Well, in order to produce this analysis, I mostly focus on consumer surplus, because the problem of the firms are actually, let's say, less interesting than trivial. So all the firms adopting the technology improve their the profit, the innovator by improving by maximizing the value, improve the profit. So the problem of the producer is actually less interesting. The problem of the consumer is a little bit more interesting. Why? Because with homogeneous companies, because all the firms adopt the innovation in equilibrium at the same price, it means that basically at the end of the day, the only improvement in welfare depends on the fact that some of the resources that previously was cost now becomes profits for the innovator. So the innovator can produce a new technology that erodes some of the cost. Those resources are now invested in prices. So you basically pay for the licensing, and that is extracted by the innovator. But because the price matches the cost saving effect, consumers do not actually see any effects on the final price. This is the general result in the literature. So with homogeneous good, with homogeneous companies. With heterogeneous companies, it's actually more interesting because you have an effect. If you want to increase the number of firms that adopt the new technology, you have to lower the price. And by doing so, you're allowing some of the inefficient firms to have some improvement in their production level. That means that the average cost of the industry falls. And that means that the price in the industry for the good is actually falling as well, and the consumer surplus is actually large. So under the heterogeneous company assumption, consumer surplus expands the more firms are served with the new technology. So the more efficient becomes the market in general. And this is quite intuitive because in the extreme case that all firms are served in the market comes from being a very unequal market to an efficient market with all firms using the highest technology, which is the previously best one available. Well, the results also, if we change a little bit the royalty rate scheme, royalty per unit is not really realistic when it comes to innovation. Usually there's an ad valorem licensing, meaning that I pay something depending on the price I set. So every transaction that I do, I have to pay a share to the patent holder. The problem becomes much more complex, but actually treatable as well. So we still have a market share effect, which is clearly negative, and we have a price effect, which depends crucially on this relationship here. So how the royalty rate affects total output, which in turn affects the price of the final good. This, of course, depends on the form of the demand function, on the functional form of the demand function. With linear demand function, this is unambiguously positive, and the analysis applies as well. So the same result. And I still have to see if with other functional forms there might be problems on that respect. So just as a takeaway, I think it's more or less everything that I had to say. Basically, it's just a repetition, but the main contribution that this analysis aims to provide to the literature is to uncover the fact that royalty licensing is not as trivial as it is presented. It actually has provide the patent holder with a richer set of options that it can employ and it can enforce in order to maximize revenues. And because royalties are actually indeed the most common forms of licensing scheme, maybe combined with some upfront payment, but mostly royalties, what we normally see in licensing problems. This is actually a relevant question that one may actually see if the ultimate objective of a policymaker is the full diffusion of a new technology. So the general improvement of the efficiency in the market. So with this, thank you very much for your attention. I know I am a little bit earlier on the schedule, but that's fine.
Questions? Well, this is I would say, demand side of this issue. What about the supply side? So then a firm who is an innovator or to be an innovator should consider the cost of this innovation, and may or may not be related what is on the market, I would say, on the technology side.
Yes.
So would you think how to endogenize, so to say?
Well, that is an exercise that I did here.
I'm sorry, I'm not familiar with all.
And I don't expect to, but just to answer the question, so yes, you can have a problem where the innovator has actually to decide not only how to license its innovation, but also how much to invest in innovation, and possibly
should be somewhat.
exactly, and basically, well, the analysis that I carried on here takes into consideration the cost of innovation, which is a proxy for the risk. So the more costly is also the more risky the new technology. One can actually model it as a risky thing. So with some probability, you draw something that is useless or very useful and very large. With this setting, so combining the analysis with a proper cost function and a proper maximization problem for the innovator who has to invest resources in order to develop the new technology. So something that reduces the cost of the other firms. What happens is what I show you briefly in the literature review section. Sorry for repeating that. That is basically it. Well, sorry, that is actually true. In this paper, I assume firms are homogeneous. So this is not actually the case. Thank you. That is actually quite, yeah, I'm sorry, yeah. What I have to see, because in this case, there is this interesting and quite nice strategy of offering a discount, which is counterintuitive. You know, you lower the price in order to maximize the revenues, which is actually consistent with the fact that you want to expand the market, and because firms are homogeneous, the only way to allow the potential of the technology is to offer it to a discounted price to some firms that kick the other out of the market. With this setting, I think that strategy might actually be exacerbated because you can give it to the most efficient one and leaving all the other firms out of the market. But I have to double check. I don't have a clear answer now. Thank you. I think it's possibly that depending on the distribution of the technologies, the innovator has more or less incentive to produce something small or something large. So if firms are very differentiated, so the most efficient is much more efficient than the least efficient, then even a small technology is enough to maximize the revenue, because I give it to her, the other one are out, that's become a monopoly, and I can extract the monopoly rent. Otherwise, you want to have something bigger. That may be interesting.
The other way would be that if I'm looking at the market as a potential innovator too, what's the distribution of the existing cost shares? And then that might somehow impact my decision to what extent to invest and to what size I'm aiming at.
Yeah.
And then that would somehow link to two sides.
Yeah, that is indeed very nice. That's actually interesting. Should point it out. But this is thank you. Yep.
I think you make a crucial assumption that the relative fees are based on the number of products you saw. And if I understood that correctly, and this makes sure that the least productive firms will buy the license. But I would guess that in many cases, you have a fixed, you have to pay a fixed amount of money for a license. And that makes sure that the largest and most productive firms are buying the license, and they compete out the least productive ones.
That is. I think that is the intuitive way of thinking, but the result might be actually quite counterintuitive. By leapfrogging, if I give you a new technology that you don't pay in terms of marginal cost, so you pay just one, you make a large fixed payment at the beginning, and then you use it, and you're free to produce it at the new cost. That it means that you're going to leapfrog the technological leader. That allows you to increase your market share by a lot. And indeed, I think that the willingness to pay for the upfront it's going to be the difference in profit you were doing before and the difference in profit you are doing now. And that is actually, this is the arrow kind of reasoning. You have actually, the leapfrog effect is larger than the monopoly effect. So the leader wanting to be the leader. So it might be, and indeed, if assuming homogeneous firms, you use how do you say, an upfront fees, that tension actually emerged, and in the literature there's a lot of analysis in that case. I must say I should actually extend this setting to an upfront fees licensing scheme to be sure that this is indeed what will happen. But I also, because yeah, it's not. I wouldn't say it's a straightforward thing. It might actually be that the least efficient firms is still the one that want to pay more, because the upfront fees depends on what we are going to do afterwards.
I'm really if you say, but it would be nice, I think, to see that it was in practice.
Yeah. That's it. I think it can be.
Any other question? Then thank you.
Thank you very much.